To today's lesson on logarithm. We have to prove that p squared equals 4 plus 2 times 32 exponent r. If log p plus 2 base 8 plus log q base 8 equal r, and log p minus 2 base 2 minus log q base 2 equal 2r plus 1. How do we go about that? So let's start from here. Okay? Let's start from here. So these are solutions. Okay, so we have to make sure that the two logarithms are of the same base before we can easily solve them. So from here we can see that log p plus 2 to the base 8 plus log q base 2 to the base 8 equal r. This is in base 8, right? And then this other logarithm is in base 2. So we have to make sure that they are the same base before we can solve them. Now I want to change this to base 2 since this one is already in base 2 so that I can easily solve them. So let's convert. So let me write that here. So convert this to base 2. So we have to convert log p plus 2 base 8 and all that to base 2. So let's do that. So when converting this to base 2 is very simple. The only thing we do is that we write our logarithm, we write another logarithm below. We write the base 8, that's the base, we write it below, and then the p plus 2 is written above. Now, the base that we want to convert this to, we write that base below here. So we've converted this to base 2. Now we do same for this. So we also convert this to base 2. So that will be log q to the base 2 over log 8 to the base 2. The base 2 equal r. Now we have to simplify this. The LCM is log 8 base 2, so we can multiply through by the LCM. So let's multiply through by the LCM. Plus log q to the base 2. So the LCM will multiply r. So we have log 8 to the base 2. So log 8 base 2 is equal to 3. So we have 3r over here because log 8 base 2 is 3. Then and repeat this one. Okay, so we can call this equation 1. Then we repeat our other equation. So from the question, the other equation is log p minus 2 to the base 2 minus log q to the base 2 equal 2r plus 1. So we have to solve these two equations simultaneously. And how do we do that? I can see that it's very easy if we add the two equations, right? Because here is positive log q base 2, this is negative log q base 2. So when we add them, the log q base 2 will go away. So equation 1 plus equation 2. When we add that, we will have log p plus 2 to the base 2 plus log q, plus log p minus 2 to the base 2 plus 0. 0 because this plus that is 0. Then 3r plus this will give 5r plus 1. So this side, we have two logarithms of the same base and they are added. So if they are added, what we do is that we write one of the logarithms and then we multiply the p minus 2. All will still be in the same base 2 equal 5r plus 1. Now, by convention, if we have something like p plus 2 times p minus 2, the answer is always p squared minus 2 squared. And we call this difference of 2 squares, okay? So when you expand this, what you have will be p squared minus 4 or p squared minus 2 squared. So another way we can write this is log p squared minus 4 base 2 equal 5r plus 1. So this is in indices. The expression we have here is in indices. Now we have to convert this from indices. Sorry, the expression we have here is in logarithm. So we have to convert this from logarithm to indices. And how do we do that? It's very simple. What we do is that we let this become the exponent of the base 2. So you write the 2, which is the base, then you let whatever expression which is in front of the equal to sign, always after the equal to sign, become the exponent of the base. Then we equate it to p squared minus 4. So we converted this from logarithm to indices. Now, this can be rewritten as 2 exponent 5r from indices times 2 exponent 1 equal p squared minus 4. When we get to this point, we have to make sure that whatever answer we are getting is following this format, the proof we are trying to have. So, to make the proof, p squared has been made a subject, so we also have to make p squared a subject from here. So, making p squared a subject, this 2 exponent 5r can be written as 2 exponent 5. Let me write that very well. Can be written as 2 exponent 5 with an exponent of r times 2. So let the 4 cross to this side, plus 4 equal p squared. Now 2 exponent 5 is 32. So 32 is 2 exponent r times 2 plus 4 equal p squared. So let's start writing this with a p squared at the left. So p squared equal. Now they started with 4 from here, so we also begin with 4 plus 2, so plus 2 times 32 exponent r. So this is the final expression we have. And this is what they asked us to do, and we've been able to prove that. So when you finish proving this, you can write as required, as proven, yeah. So that is it. This is how we solve questions on writing. That's proof questions. So thank you for your time. You can solve more questions on this. If you have any other idea or any other way of solving this question, kindly post it in the comment below, and I'll do what to check it and go through. Thank you. Have a good day. Bye bye.